Welcome to my video on the extended power rule of differentiation. This is lesson 13 in my series on calculus. So first of all, let's look at the basic definition of the theorem of the extended power rule. You remember the basic power rule we covered in an earlier video was just for x raised to some power, but now we're going to look at the g of x. So let's suppose that g of x is differentiable and let's see, then any real k, if we want to take the derivative with respect to x of g of x raised to the k power. Earlier we had done it where g of x was just like x squared or x cubed, a polynomial, simple polynomial. So now what we find out is the derivative is going to be equal to take this k out front, just like we did last time, and then we decrement the power to the g of x, but now we need to add this derivative of g of x in there. So let's do an example. So there's our basic extended power rule. Let's get familiar with by doing an example. So f of x in this case is going to be the square root of 1 plus x cubed. So we want to find the derivative of x, f of x. So in this case, our g of x is equal to 1 plus x cubed, and our k in this case is just going to be equal to 1/2, and g of x prime, the derivative of g of x, is just going to be, the 1 goes away, so it's 3x squared using our power rule. Now, substituting that back into the original equation, so the k goes out front, which is going to be a 1/2. Now we take g of x raised to the k minus 1 power. So g of x, 1 plus x cubed to the 1/2 minus 1 power. And then we've got the x squared term out there, the 3x squared. So that's going to be equal to taking the 3 out front, combining it with the 1/2. Now, 1 plus x cubed, 1/2 minus 1 is just 1/2 minus 1/2. And then we've got the x squared term. So what we're going to end up with is 3x squared times 2 times the square root of 1 plus x cubed. So this is the derivative using the extended power rule for this function. All right, so there's an example of how that works. Now I want to do one more example. So we want to find the derivative with respect to x of y, where y is going to be equal to, this time it's the cube root of 3x squared. And we can rewrite that as 3x squared to the 1/3 power. Now in this situation, our k is equal to 1/3. Our g of x is equal to 3x squared, and g prime of x is equal to 6x. So now let's use our extended power rule that tells us the derivative of y with respect to x. We put the 1/3 out front, and then we take the g of x is 3x squared. Now we decrement the power, so it's going to be 1/3 minus 1 times the derivative of g of x, which is 6x. Now it's just a bunch of algebra, getting this all in a different form. So we've got 1/3, we got 3x squared raised to the minus 2/3 power times 6x. So we can rewrite all this just by doing some basic algebra. So the 6 divided by 3 is just a 2. So we've got a 2x in the numerator. Now the denominator can be written essentially as taking the square on the inside. So that's going to be 9x to the 4th. And then that's going to be to the 1/3 power. So that's the way we could write that. Let's see if we can make that a little simpler. And we can rewrite that again as 2 times 9 to the minus 1/3 power. That's just taking the 9 out of the denominator. And then we've got x to the 1 minus the 4/3 power, because that's what we had down here. And then we were just combining it with this x. That's what this is all about right here. Now this can be written as 2 times 9 to the minus 1/3 times x to the minus 1/3, which we can rewrite this as 2 divided by the cube root of 9x. So that's going to be our derivative. So this is the derivative of this function right here. Well, I hope you got something out of this video and learned a little bit about the extended power rule. Appreciate you watching, and leave me any comments if you got any questions. Thank you. Bye.